Okay, here we have question number 11 from February-March 2017, paper 2, variant 2. Question again about transformations. And in this question, we've got a trapezium shape, okay, and it's called A, and we're told that T bracket X is the image of the shape X after translation by the vector -1, 3. What that means is any object, if you translate it, or if it undergoes a translation or transformation T, what that transformation is a translation by the vector -1 and 3. Okay, that's what that means there. Okay, so now then it tells us that my is the image of the shape y after reflection in the line x equals 2. So T basically is a transformation of some object by the vector, the transformation of some object by translating it by the vector -1, 3, and M, the transformation M, represents the reflection of an object in the line x equals 2. Now the question tells us on the grid, or asks us on the grid, draw MTA, the image of shape A after the transformation MT. Okay, so now MTA. Now when you have a transformation or a combination of transformations, it's kind of like functions. For example, when you do f, g, x, you've got to first find what gx is, and then you've got to find what f of gx is. That's what it means, f of gx. Now, MTA means you've got to first find what TA is. So you've got to first take the object A and transform it by the transformation T. And secondly, you've got to take the new position of the object A after the transformation T and transform that by the transformation M. That means we've got to do T first, and then where you end up, you've got to there carry on with M. Okay, so in this question here, I'm first going to do the transformation T on the object A, which is a translation by vector -1, 3. Now, how do you translate this shape by the vector -1, 3? Well, you choose a point. For example, let me choose this corner here. I'm going to go left 1 space and up 3 spaces. So I'm going to go, you've got to be careful about the units. In this case, it's not a problem because each square is 1 unit. Sometimes I have 2 squares as 1 unit. That means you've got to go 2 squares across. But here, 1 square is 1 unit, you go 1 square across. So you go -1 and then 3 up. 1, 2, 3. So this right angled corner is going to go over here. Now I could do the same for each of the other corners, or I could just say, okay, I know this corner is 2 spaces to the right of that one, so the other corner is going to be over there. And I know that this pointed corner here is going to be 4 spaces below there, directly below it, so that's 4 spaces, that's 2, 4. And I know that this point here is going to be 1 space below that corner, and there we've got all the 4 vertices of the shape, 1, 2, 3, 4, and then we can join them together with straight lines. Let me put that in more accurately. And then we have this line into there, and this line up to there, and this line down to there. Okay, so that is, oops, that's not very straight. Okay, so that is the transformation of A by the transformation T. A. That's the object A transformed by the transformation T, which is a translation of or by the vector -1, 3. That's the first part. Then secondly, we've got to take our new position of the object A, and we've got to reflect it in the line x equals 2. Now, x equals 2, the line x equals 2 is a line which is vertical going through 2 on the x-axis. Every point on that line, x equals 2. Okay, so for example, that point is a point 2 minus 2, 2 minus 1, 2, 6, 4, it's 2, 4. But all the x coordinates of these points are 2. So the line x equals 2 will be a vertical line passing through 2 on the x-axis. Okay, so this is a line x equals 2. And we have to reflect the shape A in this line. Now, when you reflect something in a mirror line, the image is always the same distance from the mirror line, but on the opposite side of it. And the line joining the object and the image will always be at right angles to the mirror line. So this point gets reflected one space to the left of the mirror line, because it's one space to the right of it. And this point similarly gets reflected to there. This point is 1, 2, 3 spaces away, so it's going to be 3 spaces on the other side. 1, 2, 3. And this point is 1 point below that. So we have our 4 corners of our shape, which is like a trapezium, and we're going to join them together to give us our our reflected shape. Okay, and this is MTA. This is the image of A after it's been translated by the transformation T and then reflected by the transformation N. MTA. Okay, and that is our answer. I'll mark clearly, okay, which is our answer, MTA. Okay, you should mark it clearly in case there's some confusion as to which is which. And there we have this question answered, question 11. And thank you for listening.